Hello folks, well today is another set for the trucking and farming business. It's an Audioline 345 base station, and what we're going to do first of all, we're not going to plug it in because of the two capacitors that these Uniden sets have. We need to change those four capacitors, the two 470s, the 220s, before even powering it up. Because I don't want to risk damage. As you know, the phase lock loop chip in these has been unobtainable, and we're not going to smash up another of my sets like we did for the Uniden 300 to get a phase lock loop chip. Audioline PT345 27th of October 9. It's not, going back, aren't I? 2025, and it looks to me to be 2300538, and the gentleman says that it hasn't been ruined in any way. So it's got a mains, we'll have to put a mains plug on eventually. It's got no plug, but we'll be rebuilding the power supply. So in the meantime, when we do get on to servicing this, we'll be running it off our bench power supply on its 13.8 volts, because I want to be able to measure current, and what we don't want to do is to power it up off its AC supply before that's rebuilt. So what we'll do, I think I need to go and get a tub to put some screws in. I'm sure we'll soon find one of those. I stopped using the glass little individual cheesecake receptacles because we ended up with dropping them on the ceramic floor and breaking them. So I'll just go and get a tub. We are expecting a Uniden 200, which could well come in the post today, and when that comes, that will be priority. We've also got about 4 Amstrad 901s of my own here, and they're going to get overhauled and sold on. They're all the genuine article. I've been kind of building them up for some years, and I thought, hang on, we've got too many of these. We've also got a frustrated order one, which will be sold. Right, let's get some of these screws out. I've got 40 minutes, so I've got a full session. The sessions here are 40 minutes each, and I expect to do a normal retune and test in a 40-minute session, and I expect to do something with a bit of a repair in 2 40-minute sessions. And we've got black screws here. I think we might replace them with some silver ones. You know, some of the time in these sets is all this dismantling. It's also come with an Audioline mic. They tend to be a bit bassy, lacking treble. We'll be using our standard replacement mic, and it will sound better for that, but we will demonstrate it later on on the air test. That looks like moisture down the back. So what we're looking at initially is anything obvious. And there is nothing obvious. Just make sure they're tight, or it can end up with microphony and all kinds of things. No, it doesn't look like anything's being touched. Right, we'll take the... I don't remember taking the big screws out, but I did do. Well, there you go. I'm there waffling to you and not even realising I've taken the screws out. 2 in the top. What we'll now do is to put the top on that. I think we've got these for food leftovers from Asda. That's a brand new one. So it's had plenty of use. So the first thing we're going to do is take out that, and that, and get them replaced, because these, if these go short circuit, you've got, without looking at the circuit diagram, you've got 1 or 2 of these in the audio amplifier stage. Now this is an MB3712, the audio amplifier, and they're very expensive. I mean, there's been a time when they've been £19. So they're used on video games. I'm talking about arcade type. I'm going to say Space Invaders as a generic thing, but it wasn't Space Invaders. Was it Taito who were using these on some of their games boards? And so people who are into vintage full-size amusement machine video games, it can cause these to be a higher price than they need be. So the other one here affects the phase lock loop, and the last thing we want to do is to put any stress in any way whatsoever on the irreplaceable phase lock loop chip. So I have been offered these from Brazil, and they want me to take 100 at £30 each. I wouldn't even sell one for £30, so it's not going to happen. So not putting that kind of investment in, especially at my time in life in my mid-60s. So 220 microfarad, 220 microfarad, 470, 470. And the idea is that if that one fails, the display will go out. If these fails, you could end up killing the amplifier. We just don't want to do that. So get these out. It's a shame that the good radios and their choice of capacitor, which you wouldn't have known at the time, they weren't doing it to be stingy or anything. It's like Sony with the camcorders in the 80s. The Sanyo capacitors that they used turned out to be not very good and didn't last like above 5 years. So that affected Canon camcorders, and it affected, of course, the Sony ones I've just mentioned. It affected Sanyo's own camcorders. And that's why you don't find any 80s camcorders that work without intervention. And when some of these camcorders were 3,000 quid, it's disappointing. Right, that's 1, 2, 3. Get that 4th one out. So these don't really need a full recap. It's not. You get the odd one that does, but it's rare. Right, I'm going to go and get the replacement capacitors, and while I'm at it, there's this one in the power supply, which, while I've got it in mind and I've got the thing upside down, I may as well change. Is that 220? No, it's 10. So I'll get that as well. So I want 2 220s, 2 470s and a 10. Right, I'll start by putting this one in. So we've got positive to the right, negative to the left. I'm not going to just bend the leads. I'm going to use these. I could be using long nose pliers, of course, but these happen to be here. I want to put the leads on any strain. I'll just push that down. So it's only held by the solder, there's no mechanical rigidity, which is ideal, but there you go, that's how it was and that's how it is. So that's now double the voltage and is a Nikon and not Billy No Mates. Whatever it was, HT, I mean, there's no sound, any leakage, it's probably fine, but whilst it's out, you know, just get on with it. So what we got here, we should have got a 470, making sure the glue, which can become hydroscopic, is gone. So that's that way. You can't believe that. I mean, I go to all this trouble to clear these, but no. Right, we're now going to switch on. It's come on channel 39. It's all lit up. Unfortunately, somebody's put it's got a blue LED behind it. There's always something, isn't there? I can't let that go. I'd let it, if it was a white LED, I'd let it go, but it's a blooming blue one. Blue LEDs weren't even invented when these were made. Oh dear. Yep, hoping it's a quick job today. Slight dirt on the volume control. Right, let's go through it. So we're on channel 20. I'm being dazzled by a high intensity blue LED, which I put the clipboard over. And we need to connect up the test gear to the aerial socket. And we'll put the extension speaker mounted on the wall one, the SW711 4-inch one that is, which we use for the on the air tests. Dazzle with that stupid LED. Into the public address socket. We've got the mic plugged in. I'm going to switch to PA. Testing 1 2, testing 1 2. Testing 1 2, testing 1 2. We got nothing. Testing 1 2. Right, I'll switch it between CB and PA. Try again. Testing 1 2, testing 1 2. 1 2 1 2. I think we've got a duff mic. Anyway, one thing or another, We'll see whether the mic goes into transmit. Want high power, and then high power at 13.8 volts. The radio is doing, let's put picture in picture on so you can see. Full scale. We've got full scale deflection. It's about 3 watts. So we're going to put down exactly. I could say it's 2.95, but we'll put down 3 watts. Right, change channel to channel 40. It's 3 watts. Change channel to channel 1. It's 3 watts. So it's nice and evenly spread. Let's go to low power. Put the set back to channel 20. And see what we've got on low power, and we have got 190 milliwatts, and at full power the current consumption is 743 milliamps. For what it's worth, the deviation on this test set, wow, we haven't got any deviation, have we? Because there's something wrong. Right, I hope it's not something wrong in the audio amplifier. Testing 1 2, testing 1 2. Right, we've got to take the unknown out of the equation, put that microphone on one side, and I'll get our standard Uniden test mic. There's our standard Uniden test mic, and we know it's Uniden because it says so on it. Right, see if we've got any audio now. Testing 1 2. We have, so it's a microphone problem that the customer has with that microphone. Now, of course, we don't mend mics. we keep ending up having to. While it's saying it's 2.3 kilohertz, which if it is ideal. And we can go back to public address and do that test. Testing 1 2, testing 1 2, 1 2. Got dirty mic gain. So it's a dirty volume and mic gain control. So that's that. Meter doesn't work at all on transmit. Right, let's have a look at frequency. It's not adjustable on these, and the test set's still warming up, so we'll take this with a pinch of salt. 2779108 is absolutely fine. There's no adjustments, and that's well within. It should of course be, for those people not familiar, 2779125. So it's just a bit low, and it's not a problem. It's not even a problem right down to 0.85. It doesn't become illegal until it's like 0.025. So that's fine. We will do the VCO, but not at this moment. I'll need to get the service manual for that. In the meantime, we'll dial in the receive frequency of 20. We'll have it exactly the same as this, so that we're being absolutely fair. 2779. There's no point tuning it to what it should be when it isn't. So there we are, exactly to what it's at. I'll just plug the test gear into the extensions. It's that blue LED, it's so dazzling. Try and tuck it in so I don't have to see it. So what we need is the test equipment extension speaker, which is there, and we will then need an earth putting on. apply it. I'll just put it on there for now. That's the Midland microphone I borrowed yesterday. I'll just put that back on the shelf along with the Midland I borrowed it off. That was for that Midland 48 which had been full of water. Right, let's have a look at some cyanide readings. We'll go over to the cyanide meter, we'll put a bit of decent volume on. The meter still isn't working, so the meter doesn't work on this radio. Tap, tappity tap, no meter. Right, cyanide. It sounds off frequency, so something's not right. Now these normally just under 1 microvolt. So this is actually doing quite well, but it might be because the detector or the IF's out. It's currently showing as 0.68. 0.68 microvolts. For 10 dB, 0.65 microvolts. For 20 dB, if it will do it, it won't do it. It will do it, and it does it at 1.6. No, I'll not be that cruel. 1.55 microvolts. So put the squelch to full, and yes, the RF gain is at full. So put squelch to full, and we'll see where it opens. I'll just show you the attenuator. So you can see what I'm doing. I want it to open at 100 microvolts. There's no hard and fast rule on that, but experience tells me that's the best point. You don't want a squelch that never ever opens. It doesn't open at 100. In fact, it never ever opens. So that's an easy thing. We put never opens. So we'll do the opposite. We'll put the signal generator to standby, turn the squelch down, set threshold on the radio, signal generator back on, and it's a lousy 1.65. So that's either IF or just simply out of adjustment. So we've got nil on that. LED, it's got to be replaced, not letting that go. Right. Think about the people who seem to like to put blue LEDs in 40-year-old radios. I wonder if there's some people who will get a 1937 vintage Rolls Royce and put all blue LEDs in them. Do you think that's a thing? Do you think it's the same people who do that? Right. I will just make sure one thing, and that's that our Earth isn't in any way affecting. That's 12 dB. No, that's fine. Right, let's go for transmit. We'll do a tune-up, and I'll do the VCO later on. So here we go. So I think these will all be correct. All I think it'll be is that final one, which will need setting for 4 watts. And of course, when we reinstate this power supply, we'll just make sure the power's still doing 4 watts and twiddle it accordingly if it isn't. So I can never remember whether that one's receiver transmit, and I'm really not going to get the manual out at this point. So are we showing? We want full power, which is there. So it's peak of the peak. That was absolutely spot on. That wasn't quite. I can't remember whether that's transmit or receive. It is transmit. So all those more or less correct. So we'll start on these. This is supposed to be at peak, and then the power set on the final one. That's a broken tool. That's really useful, isn't it? Does that mean we've run out of trimming tools? Have we got another one? How did that get broken? Was it the mice in the night? The mice that move the cameras about? Well, that's I'll have to see what we've got in replacement trimming tools. Chuck that on the floor, it'll get picked up in about 3 years. Catapults it across the radio. Just let that cool down a bit. I've set it to like 3.95 now, it's heated up. It's slightly low on channel 40, no, channel 1, which is the opposite to what we would expect. That's very close, and as it cools down it might be a little bit more, and I may have to trim it on the final one, but that's very close. So we've got I'm going to put 4 watts there, I'm going to put 3.95 there, I'm going to put 4.02 there. Oh, this meter of course still isn't working. The radio will be drawing more current. It's 958 milliamps, not 2.9 amps like that President one we did the other day. What was it doing with all that power? Right, low power. Now I've got no low power at all, so I think we've got a dodgy preset. Get the service all switch cleaner. It's that one, isn't it? And while we're at it, good. Right, let's waggle that one around. And see whether we've got low power. We have 400 milliwatts, that's where it should be. So we've now got 400 milliwatts there, so that's fine. So I'll need to, if I can spot a service manual. No, I can't. I'll just oh yes I can, it's here. Right, we'll do the VCO. So, service manual realistic 2000-2001 is absolutely ideal, and they want the radio to do at least 3.4 watts. So it's doing 4. Setting the VCO is here. We're on TRC 2000. Resistor 52 is test point 1. Resistor 52 is test point 1. So if I put about 5 pairs of glasses on, we'll get the multimeter out. And it's the one with no... These have all got paint on the resistors, on the kind of forming insulation on the leads, apart from the one used as a test point. So it makes it easy. So we need to select the right channel. It's channel 40 on these radios, opposite to what you do with cybernets. The channel 40 we're testing there, and we should have 3.5 volts. We haven't got 3.5 volts. Right, well, we're going to have to adjust it then, aren't we? Now, have we got another test lead? Or not? Yeah, we have. How handy. So I want... Because chassis isn't earth on these, we need to just stick that on a coil because these cans are. And I'm going to just have to pop that in for a fraction. You wouldn't expect that to have been messed with, but it clearly has. So if you don't do this, is where you end up losing channels at the top and the bottom, especially in... Oh, I'm supposed to be in transmit, aren't I? What a wally. Well, that was a flawed test. Let's go to low power so we're not heating the transmitter up. Never will know now what it was before, but it's 4 volts now. Just as a checksum, I'll make sure it's somewhere sensible on channel 1. It is 2.6, and unlike the other sets, we do the receive. They say go to test point 3, which is somewhere around there, and adjust for maximum reading on an oscilloscope. This is your receive one, but we don't need to do that. That's the adjustment they're talking about, which you're going to do test point 2 with an oscilloscope for maximum, because we'll do it on the synod meter later. Now if you were building this from scratch at the factory, you're probably not going to have any receive at all, so they need to do that, but we don't need to because it's a working set. So that's the VCO set on the radio. So no idea what it was before because I didn't check. So it's 4 volts, done. We'll do deviation. I'll switch the other test set on and we'll come back to that in half an hour. It tells you whether it's ready or not. It comes up on its display, go away and things like that if it's not ready. So receive. Want my earth back on, and this time we'll use one of the transmitter coils for an earth point, because obviously I'm going to be putting the trimming tool in the receiver ones. I'm going to start with the detector We'll put an S9 equivalent signal of 100 microvolts on, and we will look at the oscilloscope, and we're looking for maximum recovered audio. I think I'll use this RS trimming tool for this. You know what, that was absolutely spot on. So far they were all spot on. The only that wasn't quite, and that wasn't. Good. I think we'll look at the IF, because again this can be, I'd like to look at the meter to do this. I might have to see if I can unstick that meter, whatever's happened to it. There's a little bit less signal than that. I'm looking at the oscilloscope. I'll tell you what, I'll show you the synod meter. I'm supposed to be looking at the oscilloscope, the synod meter, and the meter on the front, but the meter on the front doesn't work. I can't see that. Can't see that properly. Do the front end. That's alright. That was slightly out. I got just to take my signal down a fraction. That was alright. I'll just drop the signal again. You're always backing off. As you improve it, you're always backing off your signal input from the signal generator, so you're not saturating the receiver, and that way you're going to get better and better results. And they haven't got time at the factory to do this. All they've got to do is make it go to a line, and once it reaches that line, off on the conveyor it goes. I'll see if I can get the meter, because to get those as accurate, I want to see oscilloscope, synod, and the meter on the front panel. So that is set up as best we can at the moment. I'm going to have to turn this off. We're going to have to look and see if there's anything we can do with this meter, and I find that frustrating. Right, absolutely 50-50 as to whether there's anything I can do with this meter. And it's another sad fact that out of all the burnt out meters, stuck meters, jammed mechanisms, it's the Uniden ones, on the mobiles I'm talking about, which seems to have fared the worst. Apart from those current Midland 48XLs, which I don't see many of them with working meters, even when they're 5 years old. And Midland are cheeky enough to want £29 for one, plus shipping from Italy. And you think, well, that'll be knackered as well in 5 years. How many times have you had to change a max on the meter? Right, that's the front off. A speaker grill there. Could have put that in the clothes wash. That's avalanche of test equipment. So if we take these blooming LEDs out, Then you've got a meter mounting bracket. I don't think I've ever taken one of these off before. You know what we're going to do? We're going to disconnect those meter lamps. You can have them back. Put them on his Christmas tree. We want that holder though. Christmas tree box. I'll unsolder this meter. It looks like this has been damp. Looking at the soldering. So, black to the left. So I'll ask you, I hope you're noticing because I'll be asking, because I won't remember. The first thing I'm going to do is see whether the coil has got continuity. So it might be a jammed meter or it might be an open circuit meter. We'll put that to ohms and we'll pop this across. And you can see we've got continuity, so it's not that. So we kind of get this off its mount. It's stuck there. These foam rubbery type of pad things has kind of congealed over the last 40 years. They're not glued. It's just, you know, gone funny. Then these are just sellotaped together. Other brands of adhesive tape available. We use Scotch tape. Sellotape is the leading brand. My late mother told me that Durex was the leading brand of adhesive tape before the World War II, when she worked at the hospital in the 1930s and 40s in Sheffield. It was rolls of Durex tape, and of course they went on to be better known for the condom manufacturing. These aren't supposed to be repaired, you all know that. You've got to be very, very steady. So, see what ails it. Is it simply jammed? It is. Might be able to get to the rear bearing. I think it's the rear bearing that's it's stuck with. I think we'll pause the video, you don't have to watch me fiddling with it. I seem to have freed it off. I can blow on it and it more or less returns. I don't do anything more than that. So let's hope it works sufficiently. I'll go and get some Scotch tape and we'll get that tape back together. So what I've got here is the tape on a dispenser, which really is the only way to do this in my experience. You can see where the nicotine hasn't been. Of course, if you pull too much off like me, can't even do this right. Right, so that shouldn't fall apart. We'll put that to one side and remember to take it back to Mr. Chippy's department. Put this back on. I would think the only source for these are KP77 sets, which are so awful that most people wouldn't want them. Hey, put it in. Get there eventually. I'm actually resting the radio on my forehead so that I've got it at the correct angle. And we'll switch it back on. And we have meter operation. I'm astonished. Right, I'll have to go for lunch, come back. Right, the next thing I'll do, I'll put the front back on. The next thing I'll do the big capacitor on the power supply. While I was on my feet, I went and we're upgrading it to 3300, and by getting these particular brand, it's 105 degree rated and it's 63 volts, which is double what it needs to be, but it fits exactly. Because capacitors have got smaller over the last 40 years, the point is it fits exactly, and that's a very big advantage, that you're not messing about and drilling holes in the printed circuit to fit it with a newer component. So we'll get that unsoldered. I think there's another couple to do in there, but we'll finish the actual radio before. These are glued down. You kind of got to pull on the glue. That's got that out. So it's negative towards me, because obviously I couldn't put the meter in the right way round, and that doesn't matter, but it does matter when it's a capacitor. These are expensive enough and take about 6 weeks to come. Right, negative towards me. So, at the moment it's like that. That's it. So whilst holding that and the solder, and that will just leave us with one capacitor to do in the power supply. Let's put those to one side. Let's see what that is. It's another 220 microfarad. Good. Right, we'll switch back on. And if we can find the microphone. I need the earth back on somewhere. We'll finish the alignment if the meter's working. It is. I want meter sensitivity full so I can see what I'm doing. I said I've got those two IFs to just make sure I've got them the right side. Signal meter is that one. That's to full whack. Just see whether I can see any movement either on the meter or on the other instruments. Not on that. Let's put a bigger signal on. I saw that. Drop the signal a bit. And I saw that. So I really think we are on all the peaks. Good. It does sound better as well. It's that one which was the most out. And I really needed the meter to see that. Okay, so we'll go over to the cyanide meter and we'll see what our new reading is. Before I do that, we need to check this coil. So now we've corrected the IF, the sensitivity on the sound meter is much inferior, but what we've done is improve the signal to noise. So a lot of these are only just under 1 microvolt, and this is the same once the detector's set up right. It doesn't mean it's less sensitive, it just means it's right. So I'll just look at that again. I don't think we're going to do better than that. We're at 0.9. We'll give it 0.92. So there we go, 0.92. So say it looks vastly inferior, but it isn't. For 10 dB, it's 0.7. So before there was very little difference between 10 dB and 12 dB because the IF was out. And now for 20, it's still about it's still 1.55. There's no change there, but it's not now going to sound all nasty and garbled. I'll just check the detector because it's been so far out. We'll just check the detector again. Let's put the oscilloscope on. .86 this time. I should have checked that because when they're so far out, we can be on a false. And then 10, 0.66. That remains the same. Right, I'll see if we can get the meter to read anything. Meter's going to be what we get, what we get. Well, I'll tell you what, that has set up to S9. Don't know if you can see that. And on transmit, just pop the squelch on a second. On transmit, just need to pop the pad out because it's cooled down. Take that off. Then we'll recheck that again once we've reinstated the power supply. I want to look at the meter for transmit, and that is there. Let's see if we can see that together. Centre of the red. Yep. There's not going to be a fee for this meter. There's no guarantee that it'll work tomorrow, but I've unstuck it for now. Right, I think it's been in a damp environment at some point in its storage, and that's not helped the meter. So what are we left with? We're left with squelch, and it was dire, wasn't it? I thought it was so dire. I thought I reckon the IF's out, and it was. Let's unplug that and that. So you're hearing right now 0.3 of a microvolt. And look, we can hear the set right down to 0.14 of a microvolt. So the fact we don't get a brilliant cyanide reading ever on the Uniden sets, it's not because of the matcher being that deaf, it's just the noise. I think we experimented with one and changed all the capacitors at great expense. It's not so much 10 quid's worth of capacitors, it's the 90 minutes it takes to do. I think we got a bit better, but it doesn't get you better range. It just gets you better laboratory results. Frequency, we'll just finish that off. It's now everything's warmed up. I was going to do squelch, of course, but I've got waylaid like I usually do. 2779122, 2779122. We've got deviation to do, and I'll do that right now with the test set behind me. Wow, he's a bit high, it's 3. That one, isn't it? Wow. Stretching the mic lead, I've not done the locking ring and it just twanged out at me. I think we better do the locking. Wow. There we go. So unplug from that, switch that test instrument off. It was 2.9, so although it was high, it wasn't stupidly high. But it was too high. You know, if you were listening to this radio using something like a grandstand bass or grandstand Gemini, which is the same chassis, it would be clipping, because they're really selective. Right, squelch, that's where we were trying to get to. So put the squelch to full and see if it ever opens now I've done the IF. And the answer is no, it doesn't. Well, I'd like it to open. Squelch is there. So that's 100 microvolts and it's opening, which is what I want. That's your S9 equivalent. So now let's see whether when we set the squelch on the radio, turn the signal generator to standby, park it to 0.3 of a microvolt, put the squelch to threshold on the radio, and nearly came in, didn't it then? 1 microvolt. Got to put the tone switch on, we'd have had better cyanide, by the way. So we've got 100 microvolts and 1 microvolt there. So that's now a usable squelch. We've got that set up, we've got that. Meter unjammed. That's an FOC. All the switches do what they should do. PA works and all the sockets work. Don't know about the speaker until we actually hear it. You can't always tell from a tone as to whether it's got a nasty cone or what. So all that we're left with to do, we've actually done all the radio. All we're left with is to change that 220 microfarad capacitor on the power supply. So I'll go and fetch one. Okay, so put a plug on it. UK plug for those who are not familiar with the UK, and these shrouded pins for the live and neutral. Live's the right hand one, neutral's the left, and earth is there, and it's such that if you pull on the cord, if the cord grip failed, the live hopefully comes out first, and neutral second, and finally the earth. There's 3 amp fuse in there, and then of course the radio has its own fuse anyway. So we're going to plug this in for the first time. I'm making sure I don't switch to AC, and then we can measure the voltage on the power supply, and I've done that 220 microfarad capacitor while you weren't looking. So we're plugged in. Now these sets are on all the time they're plugged in. All the switch does on the front is switch the low voltage. I'm going to say 12 volts, but you know it's 13.8. So it's not a good idea to, nice transformers, but it's not a good idea to leave these on 24/7 with the power supply running and drawing a tiny amount of electricity. Probably something like 3 watts, I really can't be bothered to check, but there we go. So let's see what's coming out of this with all nice new capacitors. If we can poke around and get a reading, that is. $15.3. Right. That's how they thought they'd get a bit more power out of it, I think. It's actually turned up to full whack. I'm going to have to get my earth lead back because I can't really hold the 2 prods and make the adjustments at the same time. I'll put it to that coil like we did before. I'll put it to that coil. I don't care what coil I put it to. So remember, we've got the radio off, but because the power supply runs all the time, that's why we're getting, well, we were getting, what's happened there? We've not got a good connection. Or it might be that you can't get a good connection if you've not got the radio switched on. That's a bit of a conundrum, isn't it? I'm going to unplug it. I've disconnected it from 13.8 volts. We'll just switch it to mains, but keep the radio off wherever the switch is. There we go. I wonder if that gives us, yeah, that now gives us, it must switch positive and negative. That gives us now a reading. The trouble is, not only are you going to ruin the radio running them at 15 volts, you're going to have a right hum as well. So that hasn't changed because I've changed the capacitors. It's changed because at some point somebody decided they were going to do what they did and turn it to full whack. So let's look at our transmit power now, and we'll get that finalised. Just a fraction over. That's channel 20, channel 40, channel 1, low power, spot on. Good, so we've got all that done. All these things you've got to check just in case somebody's done something stupid. So the only thing left to do is to put a proper meter lamp in this. And we should have got them. So have they, the they being the person who have they gone which side of the, have they eliminated the resistor? It's going to be resistor 94, isn't it? Let's see if that looks like it's been shorted out or not. No, it doesn't look like it. We'll soon find out, because if we put this bulb across and it's like a car headlight, we'll know it was eliminated. No, that's normal. So with the LED drawing a lot less current, the resistor had little effect. That's the thing about that. So we'll get this in its holder. Might have to put hot glue or something in. Might not, we'll find out. Yeah, it's a bit... I've got Bostik adhesive on here, so although that'll take some time to dry, it'll not move around. I've got no problem with them using a connector block, and we'll simply go into the connector block. Makes it easy to change. You know, it's alright having LEDs which are going to last for a long time, but not when it's that colour. I'm going to turn it off just because I'm using a metal screwdriver, just in case I end up touching chassis. There we go. I've got a meter that lights up and it's the right colour. That's nice. Meter lamp. So it's what we've used is 3300 PSU, 220 at 35 volt PSU, 10 microfarad to be 50 volt PSU, and then the radios had 2 times 220 at 25 volts, and it's had 2 times 470 at 25 volts, and meter lamp. So all that needs to do is see why their microphone doesn't work. I say we don't fix microphones, but it looks like since COVID and we've been doing a few for end users. I know this gentleman isn't an end user, but it looks like we're going to end up doing it. So I'm just going to switch to PA. Testing 1 2. Testing 1 2. Testing 1 2. Testing 1 2. So that's our microphone. I can switch picture in picture off. It's not relevant to what we're doing. So where's his audio line microphone? Where did I sling it? There. Testing 1 2. I don't know what we're going to do if it's the insert, but we're going to find out. And switch some of this test gear off as well. I'll probably talk to Mr. Chippy on. I'll give him the walkie-talkie we have on here. And, so here's a quick test. I've talked about mics. I've demonstrated mics lots of times. So we've got ground in the middle, which goes to the braid. The black wire is receive, and that routes the speaker through, and the red wire is transmit. So we know it's doing all that, but we've got no audio. So the audio comes out of the microphone, the red wire goes to here, which is the center switch contact on the other pole here, and the earth should go to the braid, so it's common with that, and then the white wire takes it down the lead to the radio. So if I poke my screwdriver with my finger on it, I should get a hum. Let's turn the volume up so you can hear. So the wire's working, so the only thing that can't be working is the insert. The chances of it actually being something we can see and repair are slim. So let's key it up again. Let's key it up again without the PTT bar. Just in case it's an earth off, let's introduce an earth. No, it's not the earth off. So the insert's open circuit. Can't say I have much trouble with this particular type of insert. The Maxon ones are the worst. So we'll get the multimeter back. And it's open circuit, you know, there's absolutely nothing there. Just in case it's something to do with the way it's soldered, which is about as unlikely as pens having teeth. That's just in case the enamelled copper wire, which is the winding, just in case it was only just touching at the factory. This is experience from church organs, which sometimes when they're on electric action use enamelled wire for the wiring, and you can go to one after 50 years and find that. No, it's open circuit. I'll have to go to stores. This may stop this radio being fixed today, in which case we'll run the on-the-air test with just the lids off, and on-the-air test will have to be done today. So we'll see if I can come back to this evening. Okay folks, well, it's no chance of an insert, so I'll put this mic back together and give it him back as it is, as a non-worker. There's a possibility we may find a business radio microphone which will do. So it's nice to be able to do these, but the only thing is all the ones we've had have now been sold or given away. We were given some which had originated from Maplin's, and we gave one back to the person who gave us those. Another one of those didn't work, so that's one of those things, isn't it? And so there we are. We've come to a full stop on a comma, as I say. We've got scrap microphones, and lots of them are electret, so no go with those. Obviously you can buy standard replacement mics. We have those available. Might just about have them available. A lot of those you're buying on the internet don't have screen leads, so they hum like a Murphy DS602 normally hums. We've got one of those probably tomorrow, Murphy DS602, which I bought because I spotted it on eBay. So I'll put that on one side, and we'll put this partly back together. Mr. Chippy gets guitar amplifiers sometimes with quite big screws, and he buffs them up on a buffing wheel, makes them a bit smarter, because they usually look like this does. Because we've had to do quite a lot with the IF alignment, you can never quite be sure, and that's why we do these on the air tests. It's all well and good into test equipment, but it's so easy to be the wrong side of the correct tuning point, and to be on a false tuning point. So we'll plug our Uniden test mic in. This isn't very visual, is it? Tell you what we'll do, we'll prop it up. I don't like things resting on the aerial lead, which is basically what I've put a pair of pliers underneath. Might just relieve the stress of that, make it a bit more visual. You might be able to just pop the zoom out a little bit on that camera. Better. So we're in public address at the moment. Testing 1 2. And we're going to go over to CB. I'm going to stand up. And I'll go and talk to Mr. We'll leave it on 19 for you to listen to those people. I'll probably use channel 31 actually. Tango 21, Mr. Chippy.
Tango 21, working.
Excellent. Right, thanks very much.
Roger that, no problem.
Right, so yeah, that sounds fine. We'll just do one other thing while I've got it in this position. That was on low power. And I'll just have a flick around the channels. Banana Roger. Right, we'll do an on-the-air test to that later. There you go, Audioline 345 PT345 from 1981 using the Uniden chassis. Thank you for watching, and a few more surprises as to what that needed and that was what I was expecting.